Hey geometry class, welcome back to our unit on the area of circles. And we're going to continue moving through with only just one other lesson about the area of circles and sectors. And we're going to get into things called segments and learn about a thing called a chord and all sorts of neat stuff. And so these are the things we're about to learn about. I'll have, again, multiple videos and try not to talk too long, but you should know me by now. Let's begin a little bit of notes, shall we? First, we're going to talk about the good review of the area of a circle. And of course, the area of a circle is, this part. And of course, since we're dealing with circles, we have to deal with pi. Okay, because again, pi is the ratio of the circle's circumference to its diameter. So it plays a pretty significant role. And if we're going to find what the area is, we will be multiplying pi times the square of the radius. Okay, so the radius is the key element of area of a circle. All right, and let's take a quick example of how that works. Okay, so we have an example here with a wrestling mat, and yay wrestling! And so we have an example here, and we're going to find the area of the circular region of the wrestling mat. And what we know is that the diameter all the way across is 32 feet. And so that is the diameter. But what we need is the radius. And as we know from our previous videos with circles, we know that radius is half of the diameter. So it's going to be that 32 feet, but divided by 2. So in this case, our radius is going to be 16 feet. All right, so that's the key element to figure out area. We know that the radius will be 16 feet. Okay, so we'll be working with that. And we know that the area is going to be pi times the radius squared, or pi times 16 squared, which is either 256 times pi, or a big number, you punch it into your calculator, and you get 804, about. Okay, so it's about 804, and then we have to use the proper units. So feet squared, or feet squared. And that is how area works. Okay, so the radius is the key ingredient. So let's make sure we are looking for that. All right, so that's how that works. So let's go back to notes. Now we talked about the area of a circle as a whole. Circle as a whole, that's funny. But now what we're going to do is talk about the area of a sector. So what is a sector? Just like an arc was a tiny piece of the circumference, a sector is a piece of the area. Okay, so when we have a circle, remember the arc length was a bit or piece of the circumference. A sector is the vocabulary for the bit or piece of the area of a circle. And just like what we did with arcs, it's all about 360 degrees, and we want to use proportions. If we think proportionality, these formulas become meaningless because there's no need to cloud your brain with all sorts of craziness just like this. If we want to find the area of this sector of the circle, it's going to be in relation to the area of the whole circle, just like the central angle is in relation to 360 degrees all the way around. Okay, so our central angle is in relation to 360, so our area of the sector will be in relation to the area of the whole circle, just like what we do with arcs. So let's see how that works, and we'll do a couple of examples. All right, so here we're going to talk about the area of a sector. Okay, and what we're going to do is leave the answer in terms of pi. Okay, so we have our given sector here, and we're going to leave our answer in terms of pi. We know the radius is 15 centimeters, and we know the arc measure is 72 degrees, which means that the central angle is also 72 degrees. Okay, so if we're thinking proportionality, we know that 72 degrees is in relation to the entire circle. So that means that the area of the sector is going to be in relation to the area of the circle. Okay, so we want to keep that in mind, and we can think proportionality. Formulas become meaningless. Okay, so that's how we can think. And I'll show you a couple of division tricks, just like we did in the last video. So we have 72 degrees is in relation to 360. So the area of our sector, which is what we need, we don't have it, but the area of our sector is in relation to the area of the circle. Remember, the 15 centimeters is our radius. So the area of a circle, of course, is pi times the radius squared. Pi times the radius squared. Okay, so we can do some neat stuff. So just like what we did in the last video, we can use cross products. Okay, so we have 360 times our sector area would be equal to 72 times 15 squared is 225 times pi. And if we have that, then we can use division, and we can see that the area of our sector, and I'll show you a trick, the area of our sector is going to be 72 times 225 pi divided by 360. So here, let me show you some tricks now. And we kind of did this in the last video, so I'll show you a couple tricks here. How do we divide all this stuff? Well, let's think. There should be some numbers that start to pop out at you. I'm going to pay attention to the 72 and the 360, because 72 and 360 both have a common factor of 9. That's what I'll start with. I know that 72 divided by 9 is 8. And I know 360 divided by 9 is 40. So we divide it by 9. And now we see 8 and 40, and something should pop out at us again. Okay, so we see 8 and 40. Did you know 8 goes into 40? 8 goes into 40 5 times. And so we're left with 225 pi over 5. And now, of course, we know 5 definitely goes into 225. So that goes in 45 times, right? So 5 goes into 225 45 times. So we are left with 45 pi. So the area of the sector then is 45 pi, in this case, centimeters squared. Okay, so if we think in relation to the entire circle, then we can use proportionality, and everything will be just fine. So let's do another example, because that's such a fun one that we should do another one. So say a circle has a radius of 4 inches. What's the area of the sector bounded by a 45-degree minor arc? And we're going to leave the answer in terms of pi. So this 45-degree minor arc is going to make a sector. Okay, and that 45 degrees is in relation to the entire circle. So that 45 degrees is in relation to the entire circle, and we need to find the area of the sector. So the area we are looking for is in relation to the area of the entire circle. And since the radius is 4, it will be pi times the radius squared. Okay, so we'll be able to figure things out that way. So if we cross multiply and divide, I'm going to do it really, really quickly now. Okay, so it's very similar to what we've done before. That means the area of the sector is going to be equal to 45 times 16 pi, and then divided by 360. So notice what happened from here. We're going to multiply area by 360, then dividing it. And of course, we multiply 45 times 4 squared is 16. So what can we do with this? Again, some simplification tricks. Where do you want to look first? I see 45, and again, I see a 9. Hopefully you do as well. 9 goes into 45 5 times. 9 goes into 360 40 times. Okay, so here we have, again, 9 going into 360 40 times. And then we can see, again, 45 and 40 are divisible, right, with each other. So 5 can go into 40 completely 8 times. And now you can see some magic happening here, so check it out. 8 goes into 16 2 times. So the area of the sector, 2 pi. Isn't that fun? So the area of the sector is 2 pi, and in this case, we're dealing with inches squared. And that's how we can work with the area of sectors. So we're going to call that video now. Come back for the next video when we talk about segments, which are neat because we get to go back into right triangle work. So that's it for now. I'll talk to you guys in a bit.